Hey everyone, Professor Baldwin here. Today we have some more factoring problems. Here we have a trinomial and our leading coefficient isn't 1, it's actually a 3. So first we want to see if we have a GCF. And we don't have a GCF. We know that right away because our constant at the end, the 1, is a 1. And at most we'd be able to factor out a 1, which isn't really a GCF. Now, because we have a leading coefficient that isn't 1, it's a 3, we need to use that key number method to factor, which means you take the coefficients A and C, which here are 3 times 1, and the coefficient of B, which is 4, and we use those values to find our factors, but this time they're factors that we use to rewrite our middle term so that we can factor by grouping. So we're looking for two numbers that multiply to 3, but they add to 4. And those two numbers would be 3 and 1. So remember, we're using these two numbers to rewrite this middle term of 4x. So 4x is now going to be composed of 3x plus 1x. And the other terms stay the same, 3x squared and a 1. So now we have 4 terms because we rewrote that middle term. And remember, 4 terms you want to group. So our first grouping, they have a 3x in common. We factor out the 3x and we have x plus 1 as the binomial that's factored out. Ideally, we want to have an x plus 1 for our binomial in the second grouping. And notice that we already have x plus 1, which means we're just going to factor out a plus 1 because we want to leave that x plus 1 there. So we're using that identity property. Now we're down to 2 terms, so we factor out that binomial they have in common, x plus 1. And left behind, we have 3x plus 1. And remember, you can always check. So to check that this is correct, we FOIL 3x squared. Outer is a plus 1x. Inner is plus 3x. And the last 2 terms are plus 1. And if we combine those two middle terms, we get back to our initial trinomial, 3x squared plus 4x plus 1, which tells us our factored form of x plus 1 times 3x plus 1 is correct.